all positive or all negative, you're gonna get a different answer, you're gonna get a wrong answer. If you made 18 negative, that is as if this thing was being thrown downwards at a 37-degree angle. Or negative 37-degree angle, however you wanna word that. So we now have the same setup before. Obviously, the math's more complicated because we do end up with a quadratic, unless you want to do it in two parts. Is that a nod? You want to do it in two parts?
I don't remember the question, actually, sorry.
Define the time. We can use the third equation, yet again, to find time using the quadratic formula. Or, if we want to bypass that, let's say you've got deep scars from childhood about the quadratic formulas. We could solve for the final velocity first, and then solve for the time without having to use the quadratic formula. Brahms the first one to express an opinion, and she said no. So let's go for quadratic. Delta S equals V I T plus 1/2 A T squared. We are plugging in the J hat information. Please do not mix and match. Negative 50 is equal to 18t plus negative 4.9 t squared. I went ahead and did the 1/2 A. It is a quadratic equation. Personally, I like the first term to be positive. That's just me. So I'm going to bring everything over to the left. So I get 4.9 t squared minus 18t minus 50 equals 0. It is a quadratic equation. There are going to be two answers. Are the two answers both positive? Are the two answers both negative? Is one positive, one negative? Is the answer imaginary? They all mean something different. I would expect one to be positive, one to be negative. And I expect the positive answer to be a greater magnitude than the negative one. Or the absolute value of the positive one is greater than the absolute value of the negative one. So t equals negative 18 plus or minus the square root of 18 squared minus 4 times 4.9 times negative 50. All over 2 times 4.9.
132.57 seconds, and then the second one is,
That seems way high there.
yeah, actually, I'm not sure why that's so high. I feel like I did something wrong, but I put all the answers in. I don't think. Did it?
Anyone else get the same thing? Did you forget the square root, or did you forget to divide by 9.8?
Never added it. I did. And then that's a negative too. Oh. Yeah. Oh wait, that's just because that's the first one. Yeah, no, that's right.
5.52.
You got 5.52?
Yeah, and negative 1.84 or 85.
Those seem more reasonable. Did you figure out what you did here?
I really don't. We just double checked.
And both are seconds.
That's a negative 15.
All right. Second. What does the negative answer mean?
That's not right. You can't have negative seconds.
But there is a meaning to it. What does it mean? All right, so you're saying that's the correct answer,
No, not necessarily. Well,
assuming that, unless Talon made a mistake.
it should be the correct answer, but if the second answer with the negative is not meaningless, then it probably means that that's what where it would have been in the second quadrant. What meaning is there to that?
Tatiana?
Would that be before it got like the object got zoomed?
In a sense, yeah. All right, remember that at this point right here, we are plugging into a math equation. What the math equation is trying to figure out is it doesn't see this object being thrown from a cliff. What it sees is a parabola. And it's wondering at what times does it cross that axis there, or that line. All it knows is that when it is 50 meters above the origin, on the way up, it's going 30 meters per second at a 37-degree angle. So this is what the math is solving. So I know that this is being thrown up, my parabola, this is gonna be shorter than this will be. So that's how I knew the positive time would be larger than the absolute value of the negative time. So it doesn't have physical meaning here, but it does have meaning. And so it is if it did go backwards in time and then we just picked it up at this point in the journey. That would be the time there. But the positive one has actual physical meaning here. Seconds. So now how do we figure out how far from the bottom of the cliff does it land? Yes. So now plug in the I hat information and we get R is equal to 24 times 5.52 plus 0. And so 24 times that.
132.4.
Point what?
40.
40?
48.
48.
So, meters. Yeah.
And I don't remember what the last one was. Is that farther or less than? No.
It's more.
It's more than it was before? Okay. Questions? Let's add to it. What's the final velocity? I'll do the horizontal part. You can do the vertical part. All right. And for those who are not sure how I did that, it's magic. Acceleration horizontally, acceleration is 0, therefore the velocity does not change horizontally, therefore it would be the same. Also, side note, I talked about if we know 3 things that we can always find the other 2 for these. This is a situation here where if I know these 3 things, and acceleration is 0, I cannot find the other 2. This is the exception to that. How do we find the vertical component? Okay. So if we plug into the first equation, we get V final, this is J hat stuff here, is equal to 18 minus 9.8 times 5.52.
-36.096 meters per second.
0.96.
Meters per second.
If we had gotten a positive number, that should have been a clue that something was wrong. Because I know right before it touches the ground, it's going downwards. So let's actually answer the question. What is my final velocity? See, if you just got this far and stopped on a test, you would lose points because it would make me go, oh, so close. Remember, we have two forms. We have rectangular and we have polar. We don't have it in either. In either. Eva, you're about to reveal the actual answer?
Maybe not, but would it be, would you have to add the I and J components to make like the full bend?
So what am I writing down?
24 I had plus, I meant minus 36096.
There's a decimal point.
Okay. And J had. Meters
Like that?
yeah. Oh, you multiply all of them by.
There we go. Now, if I ask for the final speed, we'd have to basically, in essence, go to polar form, or we'd have to use Pythagorean theorem to find the final speed and the final angle. Let's go ahead and do that for the fun of it. And typically, I would just ask what's the final velocity, and then you decide what form you want it in. But what the heck? Let's just celebrate in the math and figure out what the final velocity is in polar form. So I've got going to the right, 24 meters per second, going down 36.096 meters per second. And I want to figure out the sum of those two. And the angle. What?
34.35.
34.35?
Yeah.
It can't be. It can't be less
Yeah.
than the size.
43.35.
43.35.
Yeah.
All right, so 43.35.
Meters over seconds.
Recognize on the quiz or test, I'm not gonna be standing over you doing that. Please remember. We're not done yet, because that's just the final speed. We need the final velocity in polar form.
Yeah.
And then I'm gonna throw one other question in there, which might seem difficult at first, at least based upon previous answers on tests, but it's incredibly quite simple. All right, so you can use pretty much any of the trig functions on this one. Generally recommended to use tangent or arctangent because this answer has yet more rounding in it than either of those. However, it really doesn't matter on a quiz or test, so I'm not gonna notice that difference. So theta is the arctan of 36.096 over 24. Or I heard cosine over there, arc cosine of 24 over 43.35. Or the arc sine of 36.096 over 43.35. They should all give the same answer. If they don't, check to see if you're in radians first.
Yeah, I was like.
Theta's gonna be more than 45 degrees, I can tell you that.
What? Oh. No, I just changed it to radians.
You changed it to radians?
That's what I'm saying. Wait, you changed it to radians? Wanted to degrees?
Well, degrees is how we've generally been doing things, but if you want to do it radians, we do radians.
Oh, I'm sorry, I thought you said change it to radians, I got confused.
No.
56.38 degrees.
One small error.
Oh, no, I don't know.
direction?
I could very well believe that angle is 56.38 degrees, but the vector is not in the 58.38.
Negative.
Somebody just said it?
Negative?
Negative,
Oh.
because it's going down like that, not being shot up like that. All right, and here's the more complicated question that is actually incredibly simple. If you see the trick, it's incredibly obvious. If you don't see the trick, then if you're like most of the students, you left it blank or put down gibberish. If you are at the bottom of a cliff and you are 132.48 meters from the bottom of the cliff, and you throw the ball back up to the top so that when it hits the corner, at the top corner, it's going 30 meters per second at an angle of 37 degrees below the horizontal. What is the initial velocity? So you're basically here where the ball landed, you're now throwing it up from that spot, and when it hits the top of the cliff, it is going 37 degrees below the horizontal at 30 meters per second. How would you solve it?
Switch initial and final.
There'd be a whole lot of either gibberish or blanks. Was it Talon?
Switch the initial velocity with final velocity.
A small adjustment. If we keep I hat, J hat the way it is, we need to change the sign. So, the initial velocity would be negative 24 meters per second I hat plus 36.096 meters per second J hat. It's just the reverse of this. All I'm doing is just changing the path to go the other direction. Yeah, perhaps I was expecting too much when I put it on the test the first time. At least they prepared me for the silence. Oh, where's who? Here's who? See you tomorrow. The master set 02. I assume people know where to find it.